Yesterday I was talking about a concept which is called enhanced placement. Well, it's actually platform awareness, and that is it like groups techniques that you can use at compute nodes at servers to enhance the performance of the VNFs that are launched in there, or virtualized instance to be more generic. So by default, VMs are assigned a CPU or a set of CPUs and memory, but the hypervisor has the rights to redistribute or dynamically assign the CPU to different cores, different physical CPUs over time. And also, we don't have control. By default, we don't control the location of memory. So, for example, a VM could have a CPU in one socket and then go to the other one for the memory and things like that. Also, the sizes for memory lookups, for paging, that is used for memory lookups are by default are too short. That makes sense for VMs that have low values of memory, but if you have a large memory assigned, then it's not optimal to use small pages for looking up information. So also you have the opportunity to connect to a different switch that performs better, or even connect to, virtual switch, or even connect directly to the NIC in case you want more performance, more throughput. Okay, so that's what we're going to talk about now. So defining these techniques, switch pages allocates bigger pages to the memory that is assigned to the VMs, and this translates into a lower use of CPU when not finding information in the memory cache. And this, of course, is associated with a better performance of the VM. But for this, you need to assign in your compute nodes a specific portion of your available memory to run with this paging size. In this case, for example, we have like 40 gigs assigned for huge pages, and that's it. So you cannot go further than that in this VM for this Hackfest. CPU pinning binds a set of virtual CPUs into a physical CPU, into specific cores in the server. Again, for improving performance. NUMA, or non-uniform memory access, actually the complete name is non-uniform memory access topology awareness, is a way of making the system or the VM aware of the topology and the physical topology of the CPUs in the server, so that it can decide to belong to a single node, or if it doesn't care, put some CPUs in one node and the other ones in the other one. So you can decide where to place your VM with NUMA topology awareness. NUMA being an architecture that for multiple nodes for holding CPUs in a compute node. Then we have another popular technique that we can put under the umbrella of EPA, which is SR-IOV, which specifies or is a technique for connecting the NIC to the VM directly without going through a virtual switch, so that it can reach almost the throughput of the NIC. And it also virtualizes the NIC into dozens of different virtual PCI addresses, so that many virtual machines or virtual instances in general can share the same NIC and reach or eventually line rate throughput. So this is SR-IOV. No? It allows us to share a NIC instead of going through OVS or Linux bridging from the VMs to the outside. It goes directly to a virtual function of the NIC. This needs us to reconfigure the server once to enable SR-IOV interfaces. In OSM, we simplify the provisioning of SR-IOV. Actually, in OSM, we model the VNFs so that everything else is automated, right? We try to expose just easy and readable readable descriptors so that you can say, I want to use SR-IOV, and the rest, OSM deals with OpenStack for the rest of the configuration. So that's the case here. You create a network that uses, in OpenStack, you have to create a network, you have to create a subnet, you have to bind the port to the network, that subnet, and you have to launch the VM using that port. And then you have to go and configure the physical switches, because you are exposing a VM to the outside world, and then it's like connecting a VM to the switch. I mean physical switch, and then who configures the switch, right? You have to go and put a VLAN or an IP address or something. In OSM, you just add the bin with SR-IOV support, specify the name of the interfaces that use SR-IOV, and then model your VNF to use SR-IOV ports instead of virt.io, and then launch the network service. OSM will take care of everything else. And it can also take care of the fabric, I mean of the physical switching, by using a feature called SDN Assist. I need to update this link here because we have a new one. So SDN Assist is what is about the demo that we're seeing now. But what it does is that whenever you have SR-IOV or pass-through, which is another technique that assigns the full interface, the full physical interface to the virtual machine. Whenever you have one of those cases, you have a virtual machine in here in pink, connected directly to a virtual function, to a NIC, and then you have a switch. So open source MANO, through OpenStack, connected, instantiated the VM and connected it to SR-IOV, took care of that. But open source MANO RO can also take care of configuring the physical switch in case you have, for example, a virtual link that interconnects two VMs together. If those ports are SR-IOV, then obviously you will need to configure that virtual link in the physical world, because it's not residing anymore in the virtual world, like the examples we have seen so far. So through an SDN controller or SDN manager or whatever element is providing control or configuration management of the switch, RO takes care of interconnecting the ports that your descriptors say that needs to be interconnected. So open source MANO takes care of the full end-to-end connectivity, no matter if it goes through the physical switches. For that, for a demo of this, I will leave you with Alfonso Tierno. Before that, just a clarification. You in your VNF, you use, instead of virt.io, which is the default type of virtual interface, the interface of the VDU would say type SR-IOV. And then you just use the VLD as always in your network service, and that will make OSM take care of the rest. Okay, so now we're going to the demo. Alfonso, are you there? Are you ready?
Okay, so yeah, I'm going to. There's no facilities to make hands-on on this hands platform awareness, because it needs quite large resources. So I'm going to make a quick demo. So it's just to run in my site. Okay, so what I'm going to deploy is just as this presentation shows is two VNFs. One is a GN generator, another is a virtual VNG. So what I'm going to deploy is two VNFs that incorporates HAM platform awareness. It's requested 10 complete cores, 32 gigabytes of Hue pages, and also in this case two PCI pass-through instead of SR-IOV. So as you know, the PCI pass-through means to assign the physical NIC interface or Ethernet interface completely to the virtual machine. In this case, is the capacity of 10 gigabits per second. So the demo will show that firstly, using an OpenStack, the OpenStack deploy the two virtual machines. It's allocated in some place. So once deployed, the OSM using the SDN Assist tool through a SDN controller are going to interconnect these interfaces. So the underlay connectivity or the layer 2 connectivity is not down by the OpenStack, by the VIN, is down by the SDN controller with the 3 in this slide. Okay, so I need to show my screen. I'm going to do is using the CLI. Can you see my screen now?
Yes.
Okay, so basically we have here some beans. So I'm going to deploy in this canonical for build. Let me to show this briefly. So it's when we upload the bean, we just say that we want to use this SDN controller. This SDN controller in this line is one SDN uploaded to OSM already, and also some mapping that the static mapping that say, okay, with the concrete compute node, a concrete PC address of the interface of the compute node is mapping or is connected to a concrete switch port. Okay, now we can just list the SDN controllers. As you can see, this SDN controller that the bin is used is one of these, is this SDN controller here, is the same ID. So we can SDN controller list or show. We can just see quickly. This is basically the URL and some configuration here. Okay, if we go to this URL, I have already open here, and just refresh, we can see now that there are two flows already because there is something already running with other OSMs. So this is not part of the demo. So we are going to see later that these are going to, let's say, increase. So let's go quickly. One moment. So what we are going to do now is just to upload the packages that are this. Let me copy paste. Okay, one is conflict because it's already ceased for the project, so it doesn't mind. Now I am going to deploy it because it takes a while, and meanwhile it's deploying, I will show you the packages that are going to be deployed. So in the deployment, I put OSM create, I put the bin account, you know, a name, in this case hack, the network scenario descriptor that we want to deploy is the virtual VNG with two interfaces. In the configuration, I put the mapping between the BLD, the management BLD, and the bit network name. This is something that Gianpietro has shown you that this can be in the VNF in the descriptor, but also we can override or we can put here in the instantiation parameters. And this option of white is useful for just waiting until it is deployed. Okay, so let's say in other terminal, let's see the show a little bit the packages I'm going to deploy it. So if we just show the virtual VNG, two interfaces with the option literal just to see the content. Okay, I can see here at the beginning this is an admin that's internal of OSM. The important part is here in the PDUs that are the virtual machines. That we can see that okay, for the flavor we ask here below we ask for 32 gigabytes, but the guest EPA here is the part that we ask for enhanced platform awareness. In this case, we ask for Hue pages. So it means that the memory is completely allocated to the virtual machine. It's not shared with other virtual machines. And also for the same for the CPUs. In this case, we ask for 10 complete cores or 10 page threads that are completely assigned to the virtual machine. We have three interfaces here. The first one is for management, and we have two interfaces of PCI pass-through with that. And we have the generator is basically the same. This is the virtual VNG, and the generator is the same requirement. Just to see quickly. As you can see, it's basically the same. And regarding the descriptor, the network service descriptor, this is the one I'm using, the VNG. Let's go literal bit better. Basically, say that okay, we're going to deploy those two VNFs, the virtual VNG and the virtual VNG generator, and we are going to connect the management interfaces on one hand, and one of the data plane interfaces, the generator with the VNF on one interface, and the generator with the VNF in another interface. Okay. Okay, I go back to the NS create, and it is already done. You can see here. So if we list OSN list, sorry, is OSN NS list, we see that the hack network service is ready, and it's okay. We can enter inside. Firstly, let's see. Do you remember that there are two flows in the SDN controller? If we refresh, it appears, I think it's 8 more flows. So it's the two of the beginning are already there, but there are 8 in total 8 new flows. Here is the rules that say, okay, when it appears a packet in the port, whatever, it's go to this other port, depending on the MAC. So this is computed by the SDN Assist, and the connectivity is already done by this. Okay, so let's list the VNFs, OSM VNF list. We can see here the virtual VNG and the virtual VNG generator. Let's get this IP address. Basically, this is a command to get the IP address and store in VNG gen. And I need now to copy some configuration files because the images are not completely prepared for automated. It's not completely automated. It's I mean, these configuration files are used by DPDK are not there in the images. I already prepared. And now what I need to do is enter in the virtual machines. That is this IP address. And start the service. So make a root. Now it is configured with DPDK software. We can just, we are now inside the VNG virtual machine, in the console of the virtual machine. We can see here the Ethernet, the assigned interfaces, and it's important to see this. Okay, there are three. One is for virtual machine. Sorry, one is for management of the virtual machine, and there are other two of data plane. So what is important here is to take note of the assigned PC address inside the virtual machine, that is the 6 and the 7, because I need to edit the configuration and put this Ethernet address here in the DPDK configuration. So let me do quickly. This is because the image is not fully prepared. I mean, it's not fully automatic, because there is ways to get this information from OpenStack. This is the DPDK. You have managed DPDK, just mounting the Hue pages and loading. This line loads the DPDK driver for the interfaces, and this binds these interfaces, this PC address of the interfaces to DPDK. So when this is edited, let's execute, and now launch the. Sorry. And now launching the, let me copy paste to go quickly. And this is configuration file is one of the configuration files I have already copied before. So now it's running, and we see the stats of the packets. That is in this case 0. It's 0 because we need to start the generator. So for the generator is I go to other terminal. And basically, it's repeat the process. So it's again, we need to list the PCA addresses. In this case, it's the same, 6 and 7. So we need to configure this script of the DPDK. So let me delete this, and is this one. Is the better. Now we can launch, and now we are ready to launch the generator. Okay, and now we can see, let's press 2, just to see the stats. Now I can see that it's transmitting, and if we go back to the virtual VNG, I have here that it's running, and it's interconnect a large quantity of packets. You know, it's 12 megapackets per second. So it's a large quantity, you know, in a 10 gigabit per second interface. Okay, and that's it, the demo basically. I don't know if there is some question here.
Thanks, Alfonso. Any question for Alfonso?
We can, for example, escape the generator and see that here again the number of packets are 0. And okay, we can delete. You have some question, please go ahead. We can just delete the network service. There is also the CLI, there's also the option white that just print the progress and white until it is completely deleted because it's asynchronous. So here you can see that it's deleting the virtual machines, the networks, and also the connectivity. The connectivity is already deleted, it's in the order. So we can go to this SDN controller that I have here in the browser and just refresh. I can see that again the flows go to the original one. No, it had been destroyed, the connectivity, and the network service is deleted. Okay, that's it.
Excellent. Thanks, Alfonso. Okay, so as Alfonso showed in the demo, OSM took care of both instantiation, mapping to SR-IOV, so to pass-through ports in this case, so the full interface to the VNFs, and then took care of the configuration, the open flows in the switch, so the VNFs were interconnected together through the physical world. Okay, in this new exercise, which is going to be relatively quick, we are cloning a new package. It's a Hackfest, it's the Hackfest basic package that you saw yesterday. It's just a single VM. And we are adding that to OSM. And we are modifying the descriptor to include some other settings of EPA, which are not SR-IOV, because we don't have support for everyone here in this game. But it will be other settings like CPU pinning, memory huge pages, and no topology awareness. Okay, so I just want you to know how this works. When you set this in OSM, it will create, in particular for the hypervisor level settings like CPU pinning, no topology awareness, huge pages from memory. This will mean a creation of a new flavor with specs that tell the compute node to use these resources. Okay, so you will be able to see that a new flavor is created and assigned to your VM, and also since we added an OpenStack client to your OSM virtual machine, you will be able to see the properties of that flavor, and you will see that it's asking for some dedicated properties. And as the guide says, well, I already downloaded these packages. Now I'm going to onboard them to the catalog. Okay, and the network service package 2. Okay, and now you will find that in the VNF packages list, you will find the basic VNF example. You go to the descriptor, and inside the VDU, if you want at the end, at this level, you will put the guest EPA requirements. So you can copy and paste that from here, guest EPA. So I added these 3 lines, guest EPA, CPU pinning policy dedicated, so we are assigning a dedicated CPU, and large size of memory pages, which will take memory not from the default RAM memory pool of my compute nodes, but the 40 gigs of huge pages memory I have pre-assigned at the compute nodes. So this is it. I will update. Oh, nothing happened. Let's see. CPA. Maybe some here or here. Okay, maybe some invisible character there. Okay, I'm going to instantiate it now. So EPA test. Doesn't matter the network. We just want to see the flavor. Create. So it's creating now. I'm going to my tenant. It will create it. There we have it, and we have this flavor that was created by OSM called Hackfest Basic VM flavor. So if you will have access to this admin portion, but from your client, you can see the flavors. So you just need to authenticate to your tenant in OpenStack using or sourcing this file here. A dot or source is the same, and then running OpenStack flavor list. No, show, and the name of the flavor. And if you want, you can grab the properties. So you can see here, it asked for dedicated CPU, it asked for 1 socket, it asked for hyperthreads, large memory pages, and 1 NUMA node. What we also can see is, I can show you this. You won't be able to see it directly, but I will show you how these pages are being consumed at the pool of the server we are using for this demo. So we have still like 20 gigs available for huge pages, and those are going to be dropped until they are exhausted. So I'm going to delete this now. Okay. And these huge pages were free. So now I have 11,000 huge pages of 11,000 huge pages with 2 megs of size, which would be about 20 something gigs of memory available in this page size. So this is a configuration that you have to do in your compute node before attempting to ask for huge pages in OpenStack or OSM.